let's start with a new chapter, which is time and work. So, what is time and what is work? And what is the amount of time required to do a particular amount of work? So, how do we calculate the efficiency of a work a person is doing, and how do we compare between them? So, this chapter deals with all these things. Let's say we have a person, and B, another person. So, they both are working and they both would have different efficiencies, right? Say that one person is taking some amount of time to complete a work and the other person is doing another time of work, or is taking another amount of time to complete the work. Then we compare them both, right? And we find out what is efficient, and we find out what is the total time which is taken by each of the person to do the work, and we'll actually find out what is the time which is required by both of them together to do the work. And that's how we find out the efficiency of how a person does the work, right? So we'll talk about all these things in this chapter. So basic rules related to time and work. If a person can complete a piece of work in n days, then the work done by that person in 1 day is 1 by n. So this is basically very simple. So a person is doing a work in n days, right? Now the work done by that person in 1 day is 1 by n. You got this one? Now, if a person's 1 day's work is 1 by n, then the person will complete the work in the reciprocal of the days. So, if he is doing 1 by n work in 1 day, he'll take n days to complete the total amount of work. It's basically a very simple logic, right? Now, efficiency of the work. If the efficiency of doing a work of A is n times of that of B, then A completes the work in 1 by n times of B. So, let's see what is happening here. We are saying that the efficiency of doing a work of A, so A is doing a work with n times efficiency than B, right? The efficiency of doing a work of A is n times to that of B, right? So, the efficiency of A is more, that is n times, than B, right? So, A completes the work in 1 by n time of the time with which B is completing the work. So, basically what are we saying here? We have two people, see, and one person is very efficient. We are saying that me and another friend of mine is sitting there, and I am doing my work with double efficiency than the other person is doing the work, right? So I'll complete the work in half amount of time than the other person, which makes sense. So let's explain again. So I am sitting here, or another person is sitting here, and that person is 4 times efficient than me, right? So that person will complete the work in 1/4 of the time which I will complete the work, right? So that is the relation between efficiency of work between two people. Now, pipes and cisterns. The concepts of pipes and cisterns are connected to the idea of time and work. Pipes are connected to a tank or a cistern and are used to fill or empty the tank or cistern. In pipe and cistern, the work is done in form of filling or emptying the cistern or tank. So, consider that we have a tank here. This is a tank, and we have a pipe connected to it. So, either we have water in the tank, right? So, the water is flowing out through this pipe, or otherwise we have a storage thing and we have a pipe connecting to it, and the water is flowing into this tank, right? So, this is the concept of pipe and cistern, and the work done is in the form of either filling the tank or emptying the tank, right? So, we have two types of pipe. This kind of pipe is called the inlet pipe. Inlet pipe is the pipe which fills the tank, and this kind of pipe is called the outlet pipe. So, outlet pipe basically empties the tank, okay? Now, let's move on. If a pipe can fill or empty a tank in m hours, then the part of the tank being filled or emptied in 1 hour is 1 by m. So, this is basically very simple concept, right? So, let's say that this tank, we are filling this tank, right? We are filling this tank with water. So, we are taking m hours to fill this tank. Let's say I'm taking 2 hours to fill this tank, right? Now, the part of the tank which is filled or emptied in 1 hour. So, if I'm taking 2 hours to fill this tank, the part of the tank that is getting filled in 1 hour is 1 by 2. Does that make sense? How does this happen? I am filling this tank in 2 hours, right? Now, I'm saying that in 1 hour, how much does I fill? I fill half of it, right? Logic? Yeah. Now, if a pipe can fill or empty 1 by m part of the tank in 1 hour, then it can fill or empty the whole tank in m hours. Now, this is the reverse logic of the same thing. I am saying that the pipe can fill 1 by 3 part, 1 by 2 part of this tank in 1 hour, right? So, it will take 2 hours to completely fill the tank, right? So, half part is filled in 1 hour. So how much hours will it take to completely fill the tank? It will obviously take 2 hours to completely fill the tank, right? So that is the logic here. Generally, time taken to fill a tank is taken as positive and time taken to empty a tank is taken as negative. So when we are talking about the time taken here, if we are talking about filling the tank, we will talk about its positive because it's simply simple logic, because we are adding water here, we'll say that we'll take it as positive. Now, we are taking water from here, so we are losing water from there, so we'll put it as a negative sign, right? So, let's move on. If a pipe fills a tank in m hours and another pipes fill a tank in n hours, then parts filled by both the pipes in 1 hour is equal to 1 by m plus 1 by n. So this makes sense, right? How come? So basically, when we said that there is m hours taken to fill a tank, we say that 1 by m part is filled. Now, another pipe is taking n hours to fill the tank. So 1 by n part is filled. So the total amount of time is like the total part filled is 1 by m plus 1 by n, right? So this is the basic logic here. Now, let's solve some examples of this chapter. Ram can do a piece of work in 12 days while Sonu can do it in 15 days. If both works together, what time will they take to do the work? So first of all, Ram can do a piece of work in 12 days. So the number of days which Ram takes to work is equal to 12 days, right? So in one day, Ram works 1 by 12, right? Now, for number of days Sonu takes to work is equal to 15 days, right? Now, in one day, Sonu works 1 by 15, right? So if both works together, what will be the time they take to do the work? So let's see the amount of work they do together, right? So the amount of work they do in one day of work in one day would be equal to 1 by 12 plus 1 by 15, right? So this would be equal to 15 plus 12 divided by what is 15 into 12? 5 2s are 10, 2 1s are 2 and 3, 5 1s are 5 and 1 1s are 1, 0, 8 and 1, we have 180, so 5 plus 2 is 7, 27 by 180, we'll cut this by 9, we get 3, and here we have 2 9s are 18, 0, 3 by 20, right? So, the time which is taken by them to work is the inverse of this, which is time taken for them together to work is 20 by 3, right? Which is equal to 6 3s are 18.66 days. So, amount of days they'll take together to complete this work is 6.66 days, right? Now, so let's calculate. We have an example here. A and B can do a piece of work in 12 days, B and C in 15 days, and C and A in 20 days. In how many days will they complete the work separately, right? So here we have A's and B's. We are just calculating one day's work, okay? So for 1 day's work, A and B completes the work in 1 by 12. The amount of work done by A and B is 1 by 12, and B and C is 1 by 15, and C and A is 1 by 20. Let's add all of these equations. We get equation 1 plus 2 plus 3. It gives us 2A plus 2B plus 2C is equal to 1 by 12 plus 1 by 15 plus 1 by 20, right? So what is the common factor here? Let's see the LCM of 12, 15 and 20. So 12, 15 and 20, we take the LCM. So is 2 divisible? No. Is 5 divisible? No. So let's see. Let's make the denominator to be, let's say, we'll multiply these two then. So we go 15 plus 12 by 12 into 15 plus 1 by 20, right? So let's cancel this out. Yeah. So we have 15 plus 12, which is 27, divided by 12 into 15 is 12 into 15, 5 2s are 10, 5 1s are 5 and 6, 2 1s are 2 and 1, 0, 8, 1. We have 180 plus 1 by 20, right? Now let's make this denominator into 180. We just multiplied by 9, right? So we have 2 times A plus B plus C's 1 day's work is equal to, we have 9 plus 27, so we have 36 by 180. Now 36 and 180 I could cancel out by 6, 6 6 are 36 by 3 0. Now again by 6 I get 1 by 5, right? So A plus B plus C's 1 day's work is equal to 1 by 10, right? Now to find the number of days they'll take to complete the work separately. For A's case, what will we do? We'll subtract from the total amount of work done in 1 day from A's plus B and C's was 15 days, right? It was 1 by 15 and the total is 1 by 10. So we subtract the amount of work done by B and C from the total work. So we have A plus B plus C here. We subtract B plus C from here and we get A, right? So A plus B plus C is 1 by 10 and B plus C is 1 by 15. So 15 minus 5, 15 minus 10 is 5 by 150. So we get 1 by 30. So if A is working alone, he'll take 30 days to complete the work, right? Now let's see about B's case. Let's see how much time B would take to complete the work. So the time taken by B would be A plus B plus C's 1 day's work minus A plus C's work of a day, right? So this means 1 by 10 minus what is A plus C's total? A plus C's total is 1 by 20. So we subtract it from here. So we get 20 minus 10 is 10 by 200. So we get 1 by 20 and B is going to take 20 days to complete the work, right? Now let's talk about C. In C's case, we have to subtract A plus B from A plus B plus C. So what is A plus B plus C? It's 1 by 10 and we are subtracting A plus B from here. So what is A plus B? 1 by 12, right? So 1 by 10 minus 1 by 12 it is. So we get 12 minus 10 is 2 by 120 and we get 1 by 60. So C would take 60 days to complete the work, right? Now I hope this concept is clear. Now let's see an example of pipe and cistern. Now an outlet pipe can empty a cistern in 5 hours. In what time will the pipe empty 2 by 5 parts of the cistern? So an outlet pipe can empty a cistern in 5 hours. So in 5 hours it will empty, right? So in 1 hour it takes 1 by 5th part. It empties 1 by 5th part, right? Now in what time will the pipe empty 2 by 5th part? So in 1 hour it will empty 1 by 5th part. So 2 by 5th part means it empties in 2 hours, right? Yeah, this is the answer for this question. Now, let's solve another example. If a pipe can fill a tank in 2 hours and another pipe can fill the same tank in 6 hours, then what part of the tank will be filled by both the pipes in 1 hour if they are opened simultaneously? Okay, so first pipe, let's consider the pipe A. This fills the tank in 2 hours. So in 1 hour, it fills half of it, right? Half part of the tank is filled in 1 hour. Okay, so the same tank is taken and we take the pipe B, right? So another pipe can fill the same tank in 6 hours. So it fills in 6 hours, right? So in 1 hour, it fills 1/6th part of the tank, right? Then what part of the tank will be filled by both the pipes in 1 hour? So in 1 hour, the amount of part which should be filled would be 1/2 plus 1/6. So this would give us 6 plus 2, 8/12, right? So we could cancel 4 from here, so 2/3. So 2/3 parts of the tank would be filled by the end of 1 hour by both the pipes. I hope that concept is also clear. Now let's move on to the next example. If a pipe can fill a tank in 5 hours and another pipe can empty the tank in 10 hours, then what part of a pipe will be filled, what part of the tank will be filled by both the pipes in 1 hour if both pipes are opened simultaneously? So let's talk about filling the tank, right? So a pipe is filling the tank in 5 hours. So in 5 hours, it's filled. So in 1 hour, 1/5 part is filled, right? And another pipe empties the tank in 10 hours, right? So in 10 hours, it is emptied by another pipe. And in 1 hour, how much is emptied? 1/10th is emptied. So in what part of the tank would be filled by both the pipes in 1 hour? So in 1 hour, how much amount of water would be remaining in the pipe? So this is the case here where we have a tank, okay? So we have a pipe which is filling in water in here and we have a pipe which is taking the water outside. So it is saying that it takes 5 hours to fill this whole tank. So in 1 hour, 1/5 of this would be filled. And in 10 hours, it would take 10 hours to empty this whole thing. But in 1 hour, 1/10th of it should be emptied. So this would happen simultaneously. So how do we find out how much water would remain in the tank in 1 hour? We just subtract 1/5 minus 1/10. So we get 10 minus 5/50. So it's 5/50. So we get 1/10. So 1/10th part of the water in this thing would remain after 1 hour. Okay. 1/10th part would remain in the tank. Okay. Now, let's solve another example. Two pipes A and B can fill a tank in 10 hours and 15 hours respectively. Find the time taken to fill the tank when both the pipes are turned on simultaneously. So two pipes A and B can fill a tank in 10 hours and 15 hours respectively. So A fills the tank in 10 hours, right? So in 1 hour, it fills 1/10th part of the tank. Now B fills the tank in 15 hours. So in 1 hour, it fills 1/15th of the tank. Now find the time taken to fill the tank when both the pipes are turned down simultaneously. So here we have to find the time taken to fill the tank. So in 1 hour, let's see how much part is completed. So in 1 hour, we have 1/10 plus 1/15 part which is filled. So here we get 10 plus 15 by 150, which is equal to 25 by 150, right? So how much times 25 is 150? We have 4 times 25 is 100, so 6 times. So it takes in 1 hour, 1/6 of the tank is filled, right? So how many hours would it take to completely fill the tank? It will take us 6 hours to completely fill the tank. Now, these are some examples of how we are applying the relation between time and work to find out different procedures. So first of all, we talked about basic rules related to time and work, that is a person working on 1 by nth efficiency, and then we compared two people's efficiency, and then we talked about pipes and cisterns and how the relation is calculated. So this is all about the chapter time and work.